Let us see a cloud experiment for attendance registration using RFID and OLED display. RFID is an input and OLED is output. The flowchart explains powering the RFID to 3.3 volts, OLED to 3.3 volts, 5 volts to the ESP32, and 5 volts to the ESP32 in another kit which is already powered. Now connecting RFID to ESP32 as input in one IoT kit and output to OLED from ESP32 in another kit. Write the code in the Arduino IDE for the desired input and output device selected to perform this event. Include Wi-Fi, Arduino, Arduino JSON, PubSub client for publish and subscribe, and Wi-Fi manager to fetch from the library. Define SS pin and reset pin in any digital pin, here we assign with GPIO 5 and 4. Initially we assign string for my MAC address and set publish topic and declare the data type for tag ID, RFID state and pre-RFID state. Now inside the void setup we begin the serial monitoring function to set the baud rate. Wi-Fi.MAC address function is used here to store in any variable. Here we use my MAC address. Write serial print function to display the my MAC address value in serial monitoring. Use call function to connect with Wi-Fi, and begin the SPI and initial the PCD. Next we write the function for cloud using MQTT. Similarly, enter your MQTT server ID and port. Write serial print function to display the MQTT server address and port value. To set the port and server ID in MQTT we use the default MQTT client function. Now we get the declared my MAC address value in client ID using string function. If the attempt fails to connect with MQTT we write function to reattempt to connect with the MQTT and serial print as try again in 5 seconds. Inside void loop, we write the command to check the Wi-Fi connection. If the result is true with the username and password, it is connected with MQTT, else failed to connect with MQTT. Now we write the code for connecting with Wi-Fi. Wi-Fi.mode function is used to connect with the STA, like a hotspot. Using if condition, if Wi-Fi is connected, serial monitor print is connected to Wi-Fi network with IP. Else serial monitor print as cannot connect to the network. If the result is true with the username and password, it is connected with MQTT, else failed to connect with MQTT. Now we code for RFID loop function. Read the RFID new card is present or not by the reader. Initially assign the content as empty string. Using for loop, reading the RFID cards subsequently by the reader. If the condition is true, JSON pass the tag ID. If it's not read, JSON pass not tagged. Now save the file, verify the program and upload in ESP32. Similarly, include the header files and define the screen width and height. We begin the serial monitoring function to set the baud rate. Wi-Fi.MAC address function is used here to store in any variable. Write serial print function, to display the MAC address value in serial monitoring. Display begin using begin condition. Set the display using font style, size, cursor point and color. Specify your desired text inside display.print command. Use callback function to receive the key value from the published value. We print the value which is received from the MQTT in the OLED display. Connecting with the Wi-Fi and MQTT protocols are similar to the program written for the RFID. Now save the file, verify the program and upload in ESP32. Here the circuit diagram shows the actual wire connections being used. Connect the selected input, that is RFID, to the 3.3 volts power pin and the input pin to the GPIO 5 and 4 pin for in one kit. Connect the selected output OLED to the 3.3 volts pin. An SDA pin to the GPIO 21 pin, SCL to GPIO 22 in another IoT kit. Power both the IoT kit by connecting the adapter. Now refer the Wi-Fi video to connect the ESP32 with Wi-Fi. Now tap the card or device in the RFID and see the tag ID in the OLED display in another kit. RFID, radio frequency identification, uses electromagnetic fields to automatically identify and track tags attached to objects. These radio waves transmit data from the tag to a reader, which then transmits the information to an RFID computer program. Some of the common uses of RFIDs include inventory management, asset tracking, cargo and supply chain logistics, retail applications, etc. OLED, organic light-emitting diodes, is a flat light-emitting technology, made by placing a series of organic thin films between two conductors. When electrical current is applied, a bright light is emitted. They are widely used in electronic appliances.